How is everybody today? Good? Everybody doing good? That's good. So my name's Jared Smith, and I'll be talking about forensic analysis with using Volatility. It's a popular tool in the ecosystem for doing forensic analysis of host machines after an incident or just in general investigating the machines you have in your network. And I'm from Oak Ridge National Laboratory. I'm a research scientist there, and we'll go ahead and get started. Let's see. Oh, it's on. So we'll set this up here. Just imagine you've been compromised. It happens. It probably will happen to you if it hasn't already. And we've talked about all kinds of state-of-the-art monitoring tools and endpoint security agents, all those kinds of things. Well, those are all great, but in the case that you actually do get compromised, there's a few things you have to do. So if this happens and it turns out that, again, your logs are inconclusive, your dashboards are inconsistent, and there's freaking a ton of alerts that are coming in, which, who knows, with all this stuff we connect now, that often happens. Then what do you do at that point? So in this case, we would call our incident response team or contract one if you don't have one. I mean, I was actually kind of surprised that there was so much IR stuff we talked about here. A lot of the other people I've spoken to at dev conferences come from huge companies, and they don't even, half the time, they don't know what XSS is. So I was like, okay, this is really good to see this kind of this community, and I guess I should expect that speaking here. So call your incident response team and use memory forensics, and that's what we're going to talk about today. So my name is Jared. I'm a security researcher and project lead at Oak Ridge National Laboratory. The name might be a little familiar. We, along with Los Alamos, are the ones that developed the atomic bomb back in the 40s. And now we're the nation's largest DOE lab where we do nuclear security, particle physics, environmental science, supercomputing. We have the world's second fastest supercomputer, as well as the world's first 3D printed car was done there. And then within all of that, there's our cybersecurity group. And we have about 50 people with a machine learning team, a malware host network forensics team, and a signal RF, like radio analysis team. So we're kind of small in there out of a lab of 5,000 people, but we do some pretty cool stuff. I'm a CS PhD student at VolSec, which is the University of Tennessee Computer Security Lab. I actually just graduated with my bachelor's in December, so I'm happy to be done. And then I was hired by Oak Ridge National Lab as research staff after being there for about 2 years before that. And I used to do pen testing and security engineering at Cisco as well. There's a group in Knoxville that does all kinds of pen testing, and we would be responsible for all of the internal product security. And that was a lot of fun, but definitely a different perspective than doing hands-on research, building products, and doing defense at the lab. And then we also have a tech council in Knoxville where it's kind of growing to be a city somewhat like Austin, like Nashville, but a long way to go. And part of that is just volunteering to help build out the community and the meetups and all those things. So we're going to talk about memory forensics, and specifically memory forensics. When we're talking about this, we're talking about, at least in the case that I consider it, is examining a host memory, so in this case RAM, for anomalous data. And that anomalous data could be anything from processes that are out of the normal, or net flows, all those kinds of things. And a lot of the stuff that people do in the industry is, again, network traffic and net flow. So network forensics. And specifically, when we talk about memory forensics, we're thinking about the memory on the state of the machine. So there's lots of data there, and I'll soon show you all of that. So why not something else? In the case of memory forensics, there's reasons why you would use it over not just looking at logs. But one, you can get things like logs out of doing this by taking a full dump of your machine. And again, when you take all these logs, it's hard to get absolutely everything. So you might miss stuff. Nothing is really perfect. Endpoint security agents, as advanced as they say they are, probably don't capture the whole machine. When you take an entire memory dump of a machine, you have literally everything that was going on at that particular point in time. And then manual inspection by humans is often needed for very complex incidents. So there are tools now that will automatically verify some vulnerability in your web app or your network or something and point it out to you. But in the case of larger breaches where someone compromises a user and pivots through your network, you might not even know they're there. And when you do find the indicators of that, you need to go check out all the machines that they could have latched onto. And AI really doesn't solve everything. So as much as we want to say that we do deep learning and statistical analysis and all those things, people still need to get in the loop and actually look at the raw data that's coming off machines. So there's a bunch of tools to actually do this. So there's one called Autopsy, and then SleuthKit is part of it, or is with that as well. So that you'll see that when people talk about file carving and pulling files out of machines. So if you delete a Word document on your computer, then it could still actually be left there by the person that had deleted it, and you can see that using Autopsy by just hooking a memory dump into it. Volatility, which we'll talk about today, is a memory forensics framework. So given a memory image of your machine, you can pull out all kinds of data about it. Recall is Google's product, or it's Google's tool based on Volatility, and it forked off a few years ago to do things like live memory analysis and automatic detection of the type of OS it is, other things like that. So we're going to talk about Volatility, but pretty much everything you can do with that, you can do with Recall and more. But I like starting with the beginning. And then GRR, or GRR, is Google's wrapper around Recall, where it's basically a system that lets you keep track of all of your hosts in your network by using an agent that will actually just look at different states or pieces of the state on your machine using Recall. And they put this all into a nice dashboard and using Angular and a few other things and give it to you at an IP address in your network. So with this Volatility, according to the docs, it's a volatile memory extraction utility framework. It's a lot there. Just all it really does is just takes a memory image of your machine, whether it's Windows, Mac, Linux, Raspberry Pi, or virtual machine, really anything, and it will tell you information about it. So it takes a memory dump and extracts system state, and that state is literally everything you can think of. Not only are you getting things like files that were active at the time or references to those in the machine and network information, but you're getting syscalls that are recently called, you're getting kernel modules, you're getting DLLs in the case of Windows, you're getting console sessions that are open, you're getting absolutely every part of the machine that was going on at that time. So the architecture, it's written in Python, so it's cross-platform. You can run it on Mac, Linux, Windows. It's very straightforward, easy to use. It represents memory images as layers of objects. So basically using Python objects, it starts off with like a file address space is what it's called. And then from there, it goes down to a virtual memory address space, and it builds on top of that. And by doing that, you can treat an image that comes from a VM the same way as you treat an image that comes from a raw host. So it abstracts all of that away from you and makes it very simple to work with. And it is a plugin-based architecture for the core analysis. So all of those things I mentioned before, all of those, like process info, registry info, all of that, those are just plugins that are part of it. It's still part of the same framework. You don't have to download and install them. But that makes it great because if you want to write your own, you can just integrate it with their API. It's very straightforward to do. So the dependencies, again, it's Python 2.7 right now. It kind of sucks that it's not Python 3, but it still works. It's great. It's covered under all the security releases. Imaging software, there's something called PMM Acquisition Suite, which is by Recall. And that's what I use. It's really straightforward. You can download it, and it's just an executable on any of your machines. You just run it. It gives you a file, typically looks like a .raw file. But there's more advanced file formats, one particularly called AFF4, which is just a more advanced version of that raw file that gives you pointers into different parts of the memory. And then you can download it at their website, and the source code is all open source. It's great, and again, there's a huge community around it. So how do you actually use this? And this is where we're going to get into the nitty-gritty of what Volatility is and how it works. So first, you have to get a memory image from a target machine. So you can see here that we're using the PMM Acquisition Suite. So all we did was call the executable and pass it the name of a file we want to dump out. And then it just goes there. And I think on my VM, that happened about 2 or 3 seconds. And that was on a VM as well. So it's very quick for the amount of processing it's actually doing. And on top of that, you have to keep in mind that it actually images a file as big as your RAM is. So if you have a 2 gig RAM machine, then it's going to be 2 gigs. If you have a 16 gig machine, it's going to be 16 gigs. So it can get very intensive if you want to store all of this data, and there's a lot of trade-offs in how you do that. But it is possible to actually just take images of tons of machines and store them, assuming you have the space. And then from there, once you have that dump image, you can take it, and so here we have Volatility. It's literally just an executable. And you can ask, hey, Volatility, what is this image? Where does it come from? What's it look like? You can see here that it has a notion of profiles. So Volatility will look and tell you, hey, I think this is Windows 7 with this service pack, or I think it's OS X Sierra, or I think it's Linux with this kernel version, whatever. And it is with Linux, it's more or less agnostic of what distribution it is, as long as it's, it'd be different if it was BSD versus, the core Linux like Ubuntu. But it does a good job of picking out what those profiles are. And I told you about the file layers right here. We have the layer 2, which is the file address space, and you can see it points to the memory image. And then on top of that, it puts a page memory layer on top of it, and that actually gives you into the actual layout of the machine. And you can see this machine had one processor, Service Pack 1, and some other information. That is correct. I just did it on a VM in VirtualBox. So then this is right here. It actually gets that information about the machine by looking at the kernel debug headers. And so here it tries and looks for that in memory, and it dumps out, hey, I think this is Windows Service Pack 1. It's the major and minor version, or I think it could be Windows. Windows Service Pack 1 x86. That one's just a different version. Or I think it could be Service Pack 0. And typically, you'll run this command, you'll run it with image info and get the profile you think it is and try it with a few of them. The bad thing about volatility compared to recall is it actually needs a profile to run. It needs to know what it's pulling from. But with recall, they built some stuff on top of it where it will automatically find that for you, or at least it does a good job. So starting off, so what are the things we can do with it? The first and I guess most fundamental feature of volatility is that we can just list processes. And these are anything from they're open at the time or recently closed. They'll tell you all of that. I mean, pretty much any endpoint security agent will tell you these things, but this is doing it with just a tool in the open source community that you can just run immediately. And you can see here all of the Windows processes. So we have the kernel, we have the services.exe, all things you'd see on Windows. And again, it can run on stuff like Linux and Mac, but since malware is still primarily distributed to Windows, it's a good example just to look at that stuff. And we actually can zoom in here, and at the time when I was running this machine, you'll see this a few times, when I was running the imager, this is the actual name of that right there, I was also running PowerShell as well to run the imager. So it even pulls out what it's looking at the time it's imaging. And you can actually go into this and you can look around and say, hey, volatility, Google volatility, analyze malware. And you can see it used for actually picking out pieces of malware they're running. And that's exactly what the use case is. But here, I'm just going to show you the general things that dumps out. If we had more time, we'd do a demo. Later, if you want to see it more in action, come see me, and I'll show you it actually working against real stuff. So you can explore process hierarchies as well. This is a really cool one. So in malware, a lot of malware, they'll latch on to a specific library or executable, and they'll maybe inject a DLL or throw something else in there, and then they'll spawn off a process that shouldn't normally be under some kind of hierarchy. So SVC hosts in particular has different, doesn't necessarily run in ways that malware would try and inject into it. So if you see the SVC host spawned rootkit.exe, that's probably a bad sign. That's a very obvious one. But when you go more in depth and look at people analyzing Windows malware, this is a very key indicator of if something's actually going on. And you can see here there's the PID, the number of threads of that machine, the handles, and we'll talk about that. In Windows, handles are things like threads attached to an object, pipes, processes, mutants, which is another Windows construct, all kinds of things. And again, I showed you that we had PowerShell running. You can see PowerShell is the first one, and it spawned when pmem, which is the imager. And that makes sense because I started PowerShell to run the imager on that machine. So it is actually under that. And then it wasn't a VM, so it's running the VirtualBox, or that's actually VMware tools. You can parse the registry. This is great. I mean, if it's not going to do that for you, you probably shouldn't use it. So you can look at all of these things. And in this case, the command is just called hive list. All of these have the command up top. And you can see all the different registries. And this is way longer. I just wanted to show the basic gist of what it does. It'll show you their virtual address and the physical address in the memory. And you can actually then dump out hashes from from those hives. And here what I've done is taken the virtual address of one of the hives and the virtual address of another, specifically the I think it's the system and SAM, those two virtual addresses right there and right there. And if you do that with this hash up command, you can actually get all the hashes of that machine. So that shows you typical stuff you'd see with like Windows, and you take the hashes and try and crack them. That's exactly what we're looking at right here. You can dump out specific registry keys. So right here, I printed out Microsoft Security Center SBC. You can see the service pack number and the antivirus and firewall are turned off, which I did at the time. You can print out all kinds of information like that. And the big overwhelming point here is that these are all things you can get this tool to do. And there's a lot of innovation in the space of automating this kind of stuff. So if you, like GER does somewhat, it automates pulling out processes across thousands of machines at once. And there's, I think, my opinion is there's a lot more room for improvement in getting this very fine-grained data. So you can find recently executed commands. So here you see that when PMEM was recently executed, you have lots of information about it. I mean, it could take you like lifetimes to know what all the information this dumps out, because at that point you're going to have to tell me every single thing that Windows represents in memory, which is an awful lot of data. You can find recent console sessions. So you can see here there's conhost.exe. It shows other things like the title. It is right there, the original title and the title, the process it's attached to. And then again, this is the same plugin. I went in on it. There's PowerShell right there and WinPMEM. You can find open and closed threads, keys, ports, processes using the handles function or the handles plugin. So here you can see that the kernel has a process for that. There's a registry key that's open and it's attached to this PID. All of these are actually attached to the system process, which is just the Windows kernel. And you can see all of those PIDs, the offset in the memory, and all the different actual details of those. And if you look, this is farther down in there, and this is not, these are for different PIDs. You can see here that this process with this ID was explorer.exe. You can see that this key is open with this process. You can see VM tools was open on this process. There's all kinds of information here. And all of this will give you indicators as to whether malware is on your machine. And that's, again, why I mentioned forensic analysts, because those people are the ones that have the domain knowledge to tell you, hey, this looks out of normal. You can find loaded and unloaded kernel modules. So here we can see all of some of the DLLs and the .sys files. And this is a great place to look for rootkits. If you see that one's been loaded, it's not supposed to be there, then something's probably gone on. And again, it's got the name and the actual file it has right there. And all of these seem like they're OK. They're in System 32. If something is loaded and it looked like it was in an unusual location, you could see it. You can inspect DLLs. So in Windows, they have shared libraries, which are DLLs, and often DLL injection is a way to attach to processes and muck around with things. So you can actually see that here, that in the kernel process had these two DLLs. ntdll.dll is just the Windows API, the NT kernel, and it's got smss.exe, not too sure about that one. And then we can narrow down in and see PowerShell has all of these DLLs. So it uses all of these libraries to do things, just to do things that it would typically do. So you can, if you have, again, something that's a typical Windows process like services.exe, and it loads a DLL that it shouldn't, there's probably an issue there, and you can pick that out. You can discover open and closed network connections. So this is basically stuff that you would, any sort of network data coming in and out of your machine. At the time, I wasn't really running much, but you can see that the system is connected to this IP address, which I think that was the router where it was at. I looked it up earlier, and it was just a LAN address that wasn't routable on the internet. A lot of connections to itself. That one's listening. You can see the time it was created. And so there's definitely a lot of information there, as well as TCP or UDP. You see other things that pop up. And most of these plugins can search by regular expressions. They can filter results, and they can dump extracted objects like files or processes to disk. So if you do see a process that looks interesting to you, you can go in and say, hey, give me this process and dump it to disk. And it'll actually give you that exe out of memory as it would have been on the computer. And then from there, you can run your favorite static analysis tools against it, see weird things about it, investigate it, put it to a repository, all of that kind of stuff. So some of the drawbacks of volatility as compared to other solutions, it can be pretty slow, especially in large memory images. And Recall is great because it does improve on this a bit. Google's put a lot of work into improving the speed of it because they run it across hundreds of machines at once in their deployments. I mean, probably a lot more. And images aren't automatically detected. I mentioned that earlier. You have to specify the actual image to pass to it. But Recall does a good job of automating that. to some extent. So again, you can use that if you're interested. I wanted to cover volatility because if you get in the IR space and do forensic analysis, then you'll always see that referred to as well. And I like not jumping straight to recall. So some of the benefits, if you can use a CLI, you can use volatility. You don't have to be a programmer to use it. If you want to extend it with plugins, it's just Python. It's very straightforward. You can get almost all system state from machines under your control. So this is the big thing I like to hit home, is that no matter what agents or whatever third-party stuff you deploy in your network, with something like this, if you write wrappers around it, you can basically get all of the data about the machine at that particular point in time. It's not going to give you network data. It's not going to give you stuff like that, but you will actually see everything that was going on for that user. And with Volatility, you do get a great developer community. There's a huge open source community built around it. Every year they have a plugin contest where the community comes together and builds plugins that they vote on for who wins awards for it. So they get a regular inflow of just new stuff into the framework. So again, this isn't actually a total automatic framework. So why should I use it? Why should I spend the time actually mucking around with it and spending the time I could be building products and actually using volatility? So I think one of the possible futures that we can do with volatility and tools like it is take memory states before, just over time, take baseline states on our machines and save some amount of that data. And then as soon as we get some kind of alert from an IDS, whether it be Bro on the network or ClamAV or whatever it is, I don't know, Immunet, whatever, we can actually tell the system to take it immediately after that alert, take another snapshot and send them somewhere. And then from that, you can do a diff between those two images and see literally everything that changed between those 2 points in time. Or you can say, hey, give me the diff between this image and 10 days ago. Or if there wasn't a bad thing, you can say, give me the diff between these two baseline states. Again, there's not really a true baseline ever, unless you just booted the machine up. Who knows, someone could have tampered with it, you don't know. But again, we're assuming here that you have some known state. You can look at diffs of that. And so that's currently what I'm working on at ORNL. If you want to talk about that more, I'd love to talk about it. It's fun stuff. So takeaways, volatility is a really popular and effective tool for looking in depth at machines. It's highly versatile, and you can analyze pretty much everything with it, from your users' Windows machines or Macs. So I know some of you earlier in your talk said that, well, hey, we don't have Windows machines, so we can't use this third-party tool. Well, volatility works on basically everything. Anything that has a standard memory layout, it'll work on. And you can just go to their website, and they dump out all of the different profiles they have for it. And if they don't have a profile for something, say you want to look at Solaris, I don't know why you would want to do that, you can make one. And the future is unknown, but I do believe that focusing on forensic analysis and incident response, tooling in that area will help us in the future as more attacks come through. I think there's a lot of work, obviously, in the prevention and detection phases, but if we build more tooling into this phase afterwards, it makes the jobs easier, those people that have to protect our networks. So thank you for coming. My name's Jared. You can email me there or my personal email. I'm Jared ACoD on Twitter and on my website. And I'd love to talk more if you have time. Thank you so much. Are there any questions? Yeah.
Forgive maybe my ignorance of architecture, but if you were to do that analysis off of the machine, so you dump the file,
yeah,
and then you would take it off, do you need the swap file too?
Mm-mm. No, it's just if you have that dump file, it might include it already in there, I'm not exactly sure. But those screenshots were me running on my Mac, and the actual image was taken on a Windows 7 machine. So in some of the work we're doing at the lab, we just basically deploy the agent across a lot of Windows machines and send the image over the network every period of time, and then we look at the states there.
That's pretty cool.
Yes?
It can be used to protect against spear phishing, for example. So Office 365 does use defamation tactics and use, I wouldn't say exactly what they use, but they use something very similar. So micro VMs detonate the attachment, do the comparison, and then basically give it thumbs up or thumbs down. So that's more of kind of a scale approach of what you're using now.
Yeah, exactly. So yeah, that is a thing. And so some of the stuff we're looking at as well is if someone wants to deploy a system that looks at all these states, I think the deployment of a system that does that is going to be very specific to the group that's using it. So, a graphic design team that had a system that looked at a bunch of memory images is going to need their own deployment as opposed to the security team. Because if the security team starts running Photoshop, that's probably out of the normal for them to be running that. But if the graphic design team runs that, that's obviously different there.
It's more around analyzing the content that's being sent to a user, either through a binary or a link.
Yeah.
So then you have a robot that actually detonates this and look at comparison based on memory analysis. So very similar to what you're talking about, much bigger scale.
In Office 365 is the one you mentioned?
That's part of the protection. Yes.
Okay. Any other questions? Yes. On what? Again, sorry? Oh, containers. Yeah, so I've done it on Docker. You can take images from Docker as well. It works just fine. VMs, Docker, Raspberry Pi. Again, it's going to be proportional to the amount of memory you have, so it very much depends on what you're doing. But yeah, and I think that right now, most of the work that I've seen and people in the community, it's like, hey, we've got this Windows machine that we think is infected with the Zeus malware or something like that. And so they give you the Windows image and you have to look at all the different stuff that happened. But I think the next gen of stuff is, can we do this in AWS, and probably already being done, or Docker containers and the cloud and all of that.
Does the agent have a way to stream that memory dump back directly over the network on these small devices like a Raspberry Pi? There might not be as much storage space as there is memory.
Yeah, so the current way that there would be a few ways of doing that. So I think the most straightforward way is if you're writing an image out the file on the machine, what if you just send it over NFS? And as Volatility is writing, it's writing over the network. So that's a good way to do it. And I agree totally. If you've got a user's machine and they only have 100 gigs of space, you don't want to put, if you take images every 5 minutes, you're going to fill it up in an hour. So that is definitely a problem, and there's a lot of work to be done there. Yeah, so Azure, or if you're in AWS, they have Glacier storage. So if you want to store, who knows, terabytes of these images and go back later, I'd recommend putting them there and not in some really expensive, Azure that's not meant for long-term storage. If you want to pull them out, you can pull them out as you need them.
Are they pretty compressible?
Yeah, so in my experience, I haven't been able to compress them much, with raw files, that is. But AFF4 is another format that Google developed, or people at Google for recall, and it by nature is a compressed stream. So it is somewhat smaller, and it's easier to work with. But Volatility, being a little more primitive than recall, it just uses raw images, and I'm not too sure whether they're up to par with recall on using AFF4. And again, I'm pretty sure you can modify, if you want to make your own memory format. I'm sure Microsoft or Google, if they were going to do this, they probably have done, they might want to put work into making their own format to write out the disk. They have different requirements than those of us that have a deployment of 100 people. Any other questions? Okay, thank you so much.